Hi, this is Mr. Hoover, and I would like to talk about this exercise. An equilateral triangle has sides of length 5 centimeters. Calculate the height of the triangle. Well, as before, I made a sketch. Well, it's an equilateral triangle with the side lengths 5. Well, we know in an equilateral triangle all the angles are 60 degrees. This one, and this one. And this is the height. And as you know, trigonometry is only valid, well, our trigonometry for the moment is only valid in the right-angled triangle, okay? So we have to look for a right triangle, and this is one of these. Now we know in this right triangle, let's highlight this in red. In this right triangle, we know the angle, we know the hypotenuse, the longest side, and we want to work out one of the legs. Well, that's easy. That means we go with the sine ratio. Sine of 60 degrees is opposite over hypotenuse. Opposite over hypotenuse. We're in this red right triangle. Well, let's plug in what we know. Well, we know 5, and we want to work out h. So we multiply everything by 5. We get 5 times sine of 60 degrees. We type that in. We get this value here, and we can press the key for an approximation, and this is what we get, 5.33 centimeters, I think. Yes, centimeters. Good. Well, we could have solved this exercise by using Pythagoras, okay? We don't need trigonometry here. Well, it is very easy by using trigonometry, but well, we could have done it by using Pythagoras theorem. Let's have a look at this, because this is one of the special triangles we talked about. Well, it's an equilateral triangle, so we have a 60-degree angle, so we know all the sides are 5 centimeters. Well, the height divides this baseline into two equal parts, 2.5 and 2.5. So we could have done it like this, but how? Well, this is now 2.5, this is 5. Remember, we can use Pythagoras. H squared, one leg squared, this is the right angle, plus 2.5 squared is 5 squared. Let's isolate h, minus 2.5 squared. Let's take the square root of this, and then what do you get? Exactly the same thing. So in this case, you could have done it. But when you watch exercise 5, note there you cannot do it. You'll not do it by using Pythagoras only. Okay, so this is 4.33 centimeters. And well, in actual fact, we don't even need a calculator to get to this result. Also, a quick recap. Look, we could have done this without the use of a calculator. Well, let's try. Because 2.5 is actually 2.5 is 5 halves. So let's do this, 5 halves. So that's 25 minus 25 quarters. Well, you can square this. Now this in quarters is 100 quarters. Look, 100 quarters minus 25 quarters. That results in 75 quarters, the square root of 75 quarters. Well, now you can write the 75 as 25 times 3, and you take the root in the numerator and the root in the denominator. Well, here, up here, you're going to get 5 times the square root of 3 divided by 2. Well, obviously, we used the calculator before, but we could have done it without a calculator by the use of Pythagoras. But, well, compare the two methods. We had to fill in and understand our drawing. We had to remember that a 60-degree angle makes it a special triangle, and that this is 2.5, so it's a bit longer. This was very straightforward. I hope it's clear to you, and see you in the next one.